Hey everyone, and welcome! Today, we're going to dive into one of the most powerful and honestly simplest ideas in all of programming, encapsulation. Think of it as a secret weapon for writing code that's smarter, safer, and way more organized.
But to really get a handle on what this is, we're not going to start with a bunch of confusing code. Nope. We're going to start with a super simple, everyday object.
I want you to just picture a money box. It's got these very specific rules, right? You can put money in through that little slot, and you can take money out through a specific opening. But you can't just reach in from anywhere and grab the cash. There's a set process.
So you got to ask yourself, why? Why does it have these rules? It's not just some random design choice. There's a very, very good reason for these limits.
It's because it works. It all comes down to control and safety. These rules keep the money secure, they stop anyone from misusing it, and they make sure that everything happens in a predictable way. This simple idea, this protective, controlled system, is the key to absolutely everything we're about to talk about.
So when we take this idea, a protective barrier with controlled access, and we apply it to writing code, what's the fancy name for it?
We call it encapsulation. That's it. It's the simple act of bundling your data, your variables, and the functions that work on that data all together inside one neat little package we call a class. The data is kept safe inside, and the only way to interact with it is through these special doorways we call methods.
Okay, so we know what it is. Now let's get to the important part. Why does this matter so much? Why would we even bother? Well, it's really about taking your code from a state of potential chaos to a state of complete control.
Just look at this. It's a tale of two different worlds. Without encapsulation, any piece of your code can just reach in and mess with an object's data. That is a recipe for disaster. You get wrong data, weird bugs, it's a nightmare. But with encapsulation, the object protects itself. The data is kept safe, the rules are followed, and your code becomes so much more reliable and just easier to think about. So, how does Python do this? This is where it gets really interesting. See, Python doesn't build these giant rigid walls like some other languages. Instead, it uses a system of naming conventions, basically rules that are more like a gentleman's agreement. Let's look at the three levels.
First up, you've got public members. This is the default. Think of it as a completely unlocked door. Any variable that doesn't have a special symbol in front of it is public. It can be accessed from anywhere by anyone, no restrictions. So check this out. In our student class, the name attribute is public. That means we can create a student named Ali, and then from totally outside the class, we can just change the name to Sarah. It's allowed. Super easy, but as we just talked about, not always very safe.
Okay, next level. We have protected members. You signal this with a single underscore at the beginning of the name. Think of this like putting a "Please be careful" sign on the door. It's a message to other developers that says, hey, you probably shouldn't be touching this from outside.
So here, self.name becomes self_name. Now here's the kicker. Python won't actually stop you from changing it, but that underscore, it's a really strong hint, a convention that programmers respect. It's basically an honor system.
And finally, we have private members. This is Python's strongest level of protection. You signal this with two underscores. This is the big one. This is the "do not touch, we mean it" lock on the door. It tells everyone this data is for internal use only.
Now our attribute is self_.name. And look what happens if you try to access it directly from the outside like we did before. Wham! You get an error. Python actually steps in and stops you. This time, the rule is enforced.
So how in the world does Python do this? It's not magic. It's a really clever trick called name mangling. When your code runs, Python secretly changes the name of that variable behind the scenes. What you wrote as __name, Python sees as _student_name. It's this renaming that prevents you from accessing it from outside. Pretty smart, right? Okay, so this brings up a pretty obvious question, doesn't it? If we've locked this data away to keep it safe, how are we supposed to get to it or change it when we actually need to?
The answer is we build those controlled doorways we talked about. We create special public methods. We use a getter method to safely read the data, and we use a setter method to safely update it. This is where we can put in our rules and checks.
And this code shows it perfectly. We now have a public get_name method to read the private name and a set_name method to change it. We've brought back the ability to interact with the data, but now it's happening in a controlled, predictable way. This is the heart of encapsulation.
All right, let's put all these ideas together with a perfect real-world example that shows exactly why this is so incredibly useful.
Check out this bank account class. The account balance is private, and that makes perfect sense, right? You can't just reach into a bank account and set the balance to $1 million. Instead, you have to go through the public methods, deposit and withdraw. And look closely at withdraw. It has a rule. It checks if you have enough money first. This is encapsulation doing its job, protecting data and enforcing rules.
Okay, before we wrap this up, let's do a really quick clarification on what encapsulation is not, because there are a few common ways people get this wrong.
The main idea here is about control and data integrity. It's not about making everything a big secret. And it's definitely not a real security feature, like encryption you'd use for passwords. It's a design principle for building robust, reliable software that's easier to maintain.
So, we've seen how encapsulation gives us this incredible power of control. It bundles our data and methods together to protect that data and make our code less buggy. The real question, though, is how are you going to use this power in your own projects to build better, more reliable software?